In the previous video, we have done the comparisons between the speed of computation between Numpy and Pytorch tensors. There, we have observed amazing operation speeds while performing the computations on CPU itself. Now let's see how much computation speeds we can achieve with GPU. So to create a tensor on GPU, we have to specify the device, that is whether it should be created on CPU or GPU. First, I'll create an object representing the CUDA device like this. CUDA0 equal to torch.device and inside the parenthesis CUDA : and mention the current device as 0. When we are creating the tensors, we will pass in another parameter as device and assign the device object we have created just now, that is CUDA0. For instance, a equal to torch.once 2, 2, device equal to CUDA0. So, this will create the object at current CUDA device. And if I print the tensor A, we can see that in the output as well. So guys, tensor A is created at the device CUDA0. What it is? Tensor A is created at device CUDA0. So guys, worth noting here is we have to pass in the device parameter for each of the tensor we are creating. Now, what I'll do is I'll create one more tensor, that is b equal to torch.once and inside the parenthesis it is 2, 2, device equal to CUDA0. And now let's say we are going to add b to a. Say C is equal to A plus B. Now, if I print the C, we can observe that the tensor C also has been created at the device CUDA0 after performing the addition operation. That means, while performing the mathematical operation, we don't have to specify the device name. And one thing we have to remember is, we get the complete benefit of speed while computing on GPU when all the tensors are in the GPU. And we will not get the complete benefit of speed when one of the tensors is in CPU and another is in GPU. Now, let's do the same performance comparison like we did in the previous video. But this time, we will compare the computation speeds between Numpy arrays, torch tensors in CPU and the torch tensors in GPU. So I'll create 3 cells like this. One with Numpy arrays, one with torch tensors on GPU and another with torch tensors created on GPU device CUDA0. Okay, this is done. So I'll execute all the 3 cells. Yes, we now have the results. So to perform the operation on Numpy arrays, the system has taken around 9 seconds. And now to perform the same action on torch tensors, it took around 2 seconds. Yes, it took around 2 seconds. So this is like around 4 times the speed than the Numpy arrays. Now, here is the important observation we are waiting for. That is for the computation speed on GPU. If we see the time taken for execution, it is very fast. It just took around 15 milliseconds. Yes, you heard me right. It is just 15 milliseconds. That's how fast it is to compute on GPU. Now, let me increase the complexity of computation. This time, let's perform the matrix multiplication and I'll increase the number of loops to 1000. Yes, I'll increase the number of loops to 1000. Okay, this took a while for computing and we now have the results. The Numpy arrays took 3 minutes 14 seconds, wherein the tensor operation on CPU took 51 seconds and the tensor operation on GPU took just 1.12 seconds. So that means the things which used to take days in Numpy array can now be computed in a matter of few minutes. Yes, that's how much computation speed we get while performing the computation on GPU. So guys, I hope you now have got an idea as why deep learning is getting popular these days. With the higher computational speeds, we are now able to progress faster and able to get the required results in a very short amount of time. So guys, the total number of loops I have used for this example is 1000. Even though it may sound too much at first time, but believe me, there are times where we will come across around millions of parameters when we are solving some complex problems. So, this is why computation speed matters when performing deep learning. If we have a system which is having slow performance, then trying out a single run for fitting a data, say 1000 epochs itself, will take more time. Imagine this. You are working on a complex problem and to get the initial result itself, it will take good 12 hours. After the initial run of 12 hours, if you want to change the hyperparameters like learning rate, epochs, and the number of neurons in a layer, then to complete the trial with the new hyperparameters, it will take around 12 hours. Yes, it will take around 12 hours. So, for each trial, you have to wait 12 hours. In that case, you will be progressing very slow. So to reduce the computation time, here we are using the deep learning frameworks such as TensorFlow and the Pytorch, where the libraries are developed in such a way it can take the advantage of parallel processing and faster computations on GPUs. So guys, I hope you now have a fair understanding as why we prefer GPUs for computation while performing deep learning. In the next section, we are going to understand another feature in Pytorch, that is autograd. Let's learn more in the next section.